identified holder. And the question is, where should I go? This is where the DNS domain system comes in. And how do I get there? How do I get my package from A to B? That's what we techies call into-domain routing. And I'm lost who said it, but a name indicates what we see, an address indicates where it is, and a route indicates what to get there. So starting off, and by the way, if there's any question in between, feel free to interrupt me. Like I said, the internet covers that identified service. A web server will always be port 80, as we call it. Email runs on port 25. So when a packet comes in, the machine knows this is a web request or this is an email that's coming in. Unfortunately, we human beings are really bad at remembering numbers, especially nowadays with digital phone books. We can remember his own phone number. Beyond few. So we started using names, and those names is what we in the industry call a uniform resource locator, URL. A structured way of describing where you need to go to get a particular resource. Email, websites, file names, FTP. The added bonus there is that behind the scenes you can change the number. Whenever you change providers, your number changes. If I now my machine now has an IP address that somehow is connected to the Chatham House network, so people know where my machine is. When I get back to the office, it will get an IP address from the office. The same you can do with a web server. I can pick up a web server from a BT network to, let's say, Sky Network or anybody else, and you just simply change the number. That doesn't mean you have to create a new business card. Your email address will stay the same, your website will stay the same. So, how to connect the dots? The domain name system. Correct, the fully qualified domain name. www.ripe.net. My question for this machine, to do anything else, what's the IP address? Where do I go? So, in any network, every network has one, at least, the so-called local DNS server, or the resolver, as we call it. Your computer automatically picks up, knows where it is. That name server basically has the task to find out. So I'm gonna ask him, like, where's the IP address for www.ripe.net? Now this could be any server, so it doesn't know. So it has to go out to the internet, find out where it is. This big magic cloud, this big internet. This is where the structure comes in. So I've got a name server. Where's www.ripe.net? Dot. Mind the dot. And what's the IP address? So it goes up to the so-called DNS root server. This is where you see a lot of talk about this is also a part of the whole IANA discussion, is the root zone, the DNS root zone. It's indicated by a dot. And we're basically going to go to a DNS root server. We'll find one that's nearby and ask a simple question: where is www.right.net? What's the IP address? Now, that root server doesn't know. The only thing it knows is where .net is. So rather than say, oh, this is the IP address, because this server, he has more information about .net. So you can go and ask him. So I go out and I ask him. I ask him literally the same question: where's www.right.net? Again, the server probably doesn't know. But what it does know is where right is. Uses the second level. So it goes one down. So .net is what we call a TLD, a top level domain. And then underneath are the second level domains. And right is a second level domain in .net. So it will give another referral. It will give you another redirection saying like, you know, there's this service provider and they know, they have a DNS server and he knows everything about right.net. Is every time I get an answer or I get a redirection, I not only give an answer, there's also a timer involved. Ask a root server says, tell me where .net is, or go and ask .net. And by the way, remember this information for the next 2 days. The next 48 hours, store this. And the same goes for .net. They also use 2 days. Most TLDs use 2 days, some 3, some 1. Finally, the service provider, in our case, we give the answer back saying it's valid for 1 hour. We see things varying there between a few minutes and a few days. This is where that resolver comes in. Because whenever he gets an answer, he remembers it for the time period that it's set. So let's say I now not go to right.net, but I go to, let's say, links.net. The machine doesn't have to go back to the root because it already knows where .net is. So it can go directly to the TLD server. So once the resolver in your network knows where .co.uk is, it doesn't have to go back up the tree. It can go directly to that. How does this then translate into more or less the ICANN terms? Well, you've got the root servers, .rootservers.net. That's basically the root zone. So which servers are authoritative for .net, for .uk. That's managed by IANA. That list is kept by IANA, and ICANN has processes on how to change that and how to add TLDs, for instance. So we split it up into the generic TLDs, the .net, .org, the .everything now, .london, .wine, and the country code TLDs. Technically, there is no difference. Slight difference in the way policies are handled on the ICANN level. You see this different strategies there with the CCNSO and the GNSO. Beyond that, the service, what I described as the service provider DNS, those are operated by the registrars, mostly, sometimes the registrants themselves. I, for instance, have a few domain names that operate on my own domain server. The resolvers, the caches, usually live in your ISP network or your company's network. You see sometimes, cable modems have their own DNS server on board. Google, for instance, provides a public one, 88888. That's a public DNS server that everybody can use to perform that result. Okay. So the DNS root servers then, because that's where it all starts. Well, we've got 13 different root servers, 13 different letters. There are 12 operators involved. And there are literally hundreds. There's a little map inside and it doesn't even show them off. There's hundreds and hundreds and hundreds of these root name servers. Different software, different owners, different architecture, different countries, different continents, different networks. So there's a huge amount of diversity. If there is a bug, software fails, then it will automatically fall over and your computer will find the next one. Your computer will just simply probe with a few, find the fastest one, and it uses that one. And it keeps using that one. If it becomes available, it falls back to the other one. They all provide the same answer, and they all provide them under the same conditions. Sorry?
About the IP address, you said that for you could use the mic so remote access and yeah, that's also IP address. You said that the IP address can change if you change the location, and I'm wondering for the names, domain names, if they can change their IP address easily, or how that works. Is the IP address fixed for that name forever?
No, you can change them. It's technically not a very difficult process, but of course, if you move further up the tree, the risks get bigger. So, and you have to cater for the time to live. So the moment I move that IP address, I change it, people will remember that answer for, let's say, 2 days or 3 days. So we have to take care that I don't switch off the old machine for, let's say, the next 4 days, just to make sure that everybody is aware of the changes. But things happen. We even root servers can change their IP address. There is a list of root servers distributed, but computers, when you unpack your computer, it has a list. It knows where the root servers are. They don't change too often. If changes happen, it happened in the past, then new files get published. Your computer eventually learns where the new root servers are, and software makers will include it in updates. So the next time you buy a new machine or you install security updates, these changes get embedded in your computer. As soon as you know where the root server is, everything else can change dynamically. So even if nominate the root servers, every packet on the internet is seen by a root server. That's clearly not the case. You occasionally have a machine asking like, oh, where's .uk, where's .net? That's all you see as root server level. Also then, it's not likely cause for slow connection. You see it often in developing countries where it's like, oh, we don't have a root server, the root server is so far away. Yeah, okay, there is a slight difference, maybe between like 4 milliseconds and 200 milliseconds. But it's only one query every 48 hours, or a handful of queries. So you won't really notice it, because once you've got the answer local. So often what we see is slowness is caused at a different level. If that initial resolver is overloaded, that's where your internet connection gets slow. Because then every question you ask, you have to wait for, and not only for the root server. Having a root server in your network doesn't protect you against other failures. It's only a referral. It's great to have a root server available, but if that says go to .uk and you can't reach any of the .uk servers, you're dead. You won't get any answer. So again, this happens a lot in the developing world, where a lot of the infrastructure is outside of the country. So even if we put root name servers in the country, if the rest of the infrastructure, the rest of the chain isn't local as well, you still lose it when things go down. You always need outside connectivity at some point. Any questions so far? This is a lot of info to digest.
Can you say something about? Could you say something about the so-called Great Firewall of China and how that
web server. This is where DNSSEC comes in. DNS security extensions. Where people claim that they were interfering with the root server answers themselves, basically pretending to be a root server. We've seen cases where they intercept at the lower level. It seems to vary a bit on what they do.
Thank you. Could you say a little more about the process of dynamic versus static IP address allocations?
In general, what happens is anything that offers content or services on the internet, any computer, usually has a static IP address. The clients, like the laptops, the mobile phones, generally just get a random address from the provider the moment they connect. Technically, there's no difference. But again, if my web server would change IP addresses like every 5 minutes, I have to go back and update the DNS, which means that I can only run the TTL, the time to live, so the timer for the amount of time my IP address is valid, which overloads the system. It can be done. I can give my machine, and some people do that when they host services at home, they use what's called dynamic DNS servers. So in the background, there's a system that the moment the computer's IP address changes, goes back and updates a name server record to point to the correct IP address. It's a lot of work in the background, and it creates a lot of additional load for the DNS system. The moment you run with static, or basically there's no IP address static, like I said, you can always move it, change it. But you've got IP addresses that are long-lived for months, years, then you also can run DNS servers and DNS sounds that are long-lived, so you don't have to go in and update all these servers all the time. And that's where caching obviously benefits. Anything else on top of this? I got see two more questions.
I'm sure this will just be revision, but you said root servers don't send any packets. So that very high level, they're used to divert questions. So this is where you should be asking the question, sort of lower level. That's it. That's
that's
their job.
So they do send they obviously do send receive questions if you ask it. Do send receive packets, because if you ask it the question, you get the answer. But the actual web content or anything, that's not seen by the only thing the root server sees is, and it's not even you. It's usually the resolver asking it on your behalf. So the root server doesn't even know who you are. There's a machine on the internet that says like, oh, where's www.right.net? It gives you a referral. We don't even know whether it's your machine or anybody else.
Who pays?
Who pays? Root server operation, you mean? It's basically the 12 operators. RightNTC is a operator. We operate K-root. We are a membership organization, and part of the membership fees goes in operating one of the root name servers. ICANN operates one that's obviously done via the ICANN funding mechanism. The Swedish Internet Exchange, NetNode, has one. So every party finds their own funding mechanism, but it's usually part of a not-for-profit that allocates some of their budget to this. In the lower level, like for instance .uk, it's basically nominous business to operate name servers. So every time you register a domain name, you pay a small fee to Nominet or whoever has the TLD, and from that money they can operate the registry and infrastructure. So that's what pays for the DNS.
Sorry, thank you. My question is, with the change in internet protocols, for example, IPv4 to IPv6, are there any conflicts, or is there any danger of conflicts, or is it just straightforward and all the servers are up and running and understand both? Thank you.
Yeah, there are no conflicts. It's by design. IPv4 and IPv6 are not compatible, so they don't interfere with each other. When it comes to DNS, I can basically ask two questions. I can ask, can I have the IPv4 address for Right.net, or can I have the IPv6 address for Right.net? Now, as soon as my computer has an IPv4 and an IPv6 address, it will automatically probably ask for both and then figure out whatever comes first. And with name server operations itself, all root servers have IPv6. Most CCTLDs also have both IPv4 and IPv6 server addresses available. And I can, for instance, use IPv6 to ask for an IPv4 address or vice versa. So it doesn't. The content is independent from the transport. And I can use v6 as a transport, and I can ask whether I ask v4 or v6.
Can I ask another one?
Yeah, sure.
It's slightly different. It's about email addresses, we live in an age where an email address becomes part of ourselves. It's a part of our quantified self. I had my ISP address now for 15 years, and so this is how the outside world knows me. If I choose to change ISP, there's a serious risk I won't be able to change that address. I can't port my email address. Is there any technical reason why I can't do that?
Technically, you can always forward email. That's the last, basically the part behind the @ sign is a domain name. So that's when I send an email. Essentially, what happens around the background is it looks at that domain name to figure out where to send that email. So if that's your ISP, then it's going to send that email to your ISP. That needs to know where it goes. Now, right now you're a customer, so they'll happily take it and make sure it makes available to you. If you leave them, then it basically becomes a commercial trade-off. You're no longer a paying customer, so why should I provide a service to you? And whether the service is forward, email, or store it or make it available, it's a simple commercial decision from a service provider perspective. Am I going to provide this service? Am I going to provide this email address behind this domain name? That's the trade-off. So this has nothing to do with DNS or routing. It's basically the email will always end up with the ISP, and what they do with it, it's between you and the ISP. I'm happy to take other questions later on at the breaks as well. Looking at the clock, I'll think of how do I send my packets across the internet? Again, history is the same. We started off with something static. Oh, the IP address, you can go there. For those IP addresses, you can go there. Mostly every computer on the internet has this little static file that kind of mapped out the internet, which is great if the internet has 12 computers. Slightly more difficult if the internet has a few billion machines. So they came up with the border gateway protocol. There have been a recent couple of articles on the Washington Post. I recommend reading them about all kind of security and insecurities of BGP. Yes, it's very old and it comes from a time when everybody trusts each other, as you'll see soon. There are still other alternatives around, but BGP kind of became the de facto standard for interdomain routing. So this is part of our usual wrap. Internet routing. It's non-hierarchical, it's open, and it's free. There's no central control entity. With DNS, I always have this root zone that I need to go to. There's no such thing with routing. The routing table is completely open, bottom up, put it all together. Every network can participate. Doesn't really matter how big or small you are. If you've got the right connection and you adhere to some technical standards, you can participate. It's free, basically meaning you pay for your operations, you pay for your network capacity, and everybody does that and changes their network. And of course, you can connect to everybody. Doesn't matter. Before we go on, two definitions. What we call an autonomous system, AS, and RIPE distributes so-called ASNs, autonomous system numbers. So every network that falls under a single administration, meaning they will treat a similar packet in similar circumstances, similar way. That's kind of the idea of single administration. There's a group of people that determines policy and everything is configured in a similar fashion. Identified by an ASN, that's sort of how the internet sort of keeps track of who to. Pairing, well, in this context, pairing is any connection between two ASNs that exchange routing information. So how does this then work? So-called route announcement. Well, here's an autonomous system, AS1, and AS1 has got a set of IP addresses. This is a larger block. This is /21 indicates that this block is, what is it? A 2000 addresses. So this is 2048 IP addresses. And address range you can send to me. It's kind of similar as sorting packets at a post office. Now, if it says London, it goes to this van. If it says Birmingham, it goes into this van. What we now call technically, these two are connected, these two are pairing. Both have a routing entry for each other so they can exchange traffic. What happens if we grow the network? Let's add AS3 to the equation. And AS3's got another separate set of IP addresses. And a similar message exchange happens between AS1 and AS3. So again, hello, here I am, these are my network, these are my addresses, any traffic you can send to me. So AS3 makes another note in this routing table and it now knows how to reach AS2 and AS3 and which addresses. That's not all, because AS1 then goes back to AS2 and say like, hey, you know, any traffic I have for this block, you can send it to me, because I now just learned from AS3 that they have those addresses, so I know how to get the packet to the destination. RM, feel free to use me. So AS3 marks a node as well. Mind you, the routing table now says, oh, for this destination, I can go via AS1, who learned it from AS3. AS3 is what we then call the origin ASN. So this is the actual originating network. This is where IP address. This is where the IP addresses come from. And you gradually build up this path, because of course with AS2 has got somebody behind him, you will relay it back again. So you build up this whole huge knowledge. So what we call AS1 is the transit for AS3. Now, picking up further, AS3 and AS2 start connecting, and some message exchange happens. So, hello, AS3, here we go. And AS2 makes another routing. So if we say AS2 and AS3 are pairing, they're directly connected. Now let's say I'm in AS2 and I'm going to send a packet to anything starting with 10.16. Which route would I take? I go direct. That's the shorter one. Well, the basic rule is I'll take the shorter connection. And so the Order Gateway Protocol works. We calculate path, and when we say path length, we don't calculate routers. You simply look at how many networks are involved to get my packet to the destination. Shorter the better. Sometimes it means that things are configured differently, because shorter doesn't always mean cheaper. So maybe somebody says like, you know what, I can live with the detour because it saves me money. The detour is free, the other one I have to pay. The other big thing is you can only control outgoing traffic. So while AS2 can say like, I'm going to send I can send the packet directly to AS3. AS3 might think differently. It might send it to AS1, who's going to send it to AS2. You decide where to send it next, which means that in a message exchange between two machines, the packets that go up and down can take different paths, which becomes very critical if you start, for instance, looking at traffic interception at an exchange point, because you might only see a single flow. You have to be as close to the customer as possible to ensure that you've got both sides of the conversation. So it can be a different country. It doesn't have to, for instance, traffic downstream can stay in the UK while the enter goes back via the Netherlands or France. Commercial translation then, because well I said, technically any ASN that connects is what we call pairing. Commercial translation pairing is usually what's described as the settlement-free connection. It's based on mutual benefit. Hey, let's connect up. Your customers can talk to my customers. This is where internet exchange points like links, like LoanApp comes in. That's basically what they do, bring a lot of people together who connect. Bigger networks often connect directly. You know, Netflix has direct links with all major ISPs because Netflix customers sit in those ISPs. Usually, it's sort of smaller guys pair with smaller guys, bigger guys pair with bigger guys. You have to reach an agreement of mutual benefit, you sort of have to be on equal footing. You have to be on a similar size. Anything else? It's usually referred to transit, meaning that one party pays the other to get packets moved across. Usually the smaller one pays the bigger one, but it can be different. Billing then usually is peak capacity per month. We as end users are usually used to, oh, you pay for 5 gigabytes a month. Traffic capacity is usually just looked at, okay, where's your spike? And that's how we bill, because that's where you need to track the network capacity. So that's routing. Basically getting the packets from A to B. It's very simple. 15 minutes and 4 slides left, so I can take a few questions. I'll leave it at 5 questions.
A question on the transiting. This is an issue that, as a representative of the UK government, we get in international fora, particularly a governmental forum in which developing countries say that they're having to pay a huge amounts to more developed countries. In your opinion, would the installation of more IXPs, Internet Exchange can't remember what the P stands for now, but would that solve the problem, or would there still be more transitional payments?
IXPs can certainly help, but IXPs, when they start up, usually help when it comes to local traffic exchange, so traffic that stays within the country. International bandwidth eventually will benefit from it when other people can connect up to that exchange. And what I often observe is that you need more than just an internet exchange. Because, for instance, for an internet exchange to succeed and for an international carrier to say, like, hey, I'm gonna go to that internet exchange, I need a regulatory environment that's willing to accept it. Because a lot of these countries have very strict rules on whether you can come into the country and provide these services. What also really helps is if there's a competitive market for fiber access. You have a very strong incumbent that basically has a monopoly on selling transit and selling capacity to the internet exchange. You usually see that they cost the same. So the internet exchange doesn't get any cheaper because I need the fiber into the exchange building, and usually I sometimes even pay more than just buy the transit of them. So it's I know that it's always an easy rep, like, oh yeah, we need an internet exchange. Yes, of course you do. But with the internet exchange, I also need the environment, both in market terms and in regulatory environment, to make it interesting for, let's say, the level 3s, the cable and wireless, and all these carriers to say, you know what, I'm going to go there. And then, of course, it depends on how many access points are there. Because if there's only one subsea cable landing there, I've got essentially another monopoly to deal with. Because I have to buy capacity there. Who owns it? And is going to sell it to me for cheap? So it's on the path, but it's not the only solution, or it's part of the solution. Let's put it that way. Any other questions? Dazzling. Yeah, no, this is a lot of content to sink in. Feel free to rush me otherwise. Final bit then. This morning, the opening session talked a bit about the transition of the AM stewardship. How does this interact with all this? How does this interact with the technology? She said, what are the IANA functions? Well, basically, it's just a bunch, as I described, these static files. Essentially, IANA is still a bunch of these static files. .uk is operated by Nominet, and this is the list of the node servers. .net is operated by, this is VeriSign, I believe. This is a set of name servers. If you need .nl, this is the set of name servers, and SIDN is the authoritative people who control it. Internet number similar. This block of IP addresses is administered by RIPE-NTC. This block of IP addresses is administered by ARIN. If you need anything more, go talk to them. Then there's this huge set, what we call protocol parameters, that for instance is registering that says like, oh, port 80 is HTTP. That's controlled by the IETF. Again, it's a bunch of lists. There's a few hundred of them, or even a few thousand. So the IANA functions operator, as it then called, and right now that's ICANN, is responsible for maintaining these registries. So when Nominet wants to and they're requesting the change actually works for Nominet, is authorized to make this change, and then the next step is that the UK government verifies that IANA is done the right verification, and then it get all served. So ICANN has been doing that since 2000 under a contract with the US government, and that's going to change. The only thing that's going to change is that contract. So the ground rules, the transition proposal, support and enhance the multi-stakeholder model, And important, maintain the security, stability, and resilience of the internet DNS and the internet in general. So there are no technical changes here. It's not explicit, but this is truly an administrative change in the background. The IANA oversight transition doesn't mean that the IANA another that's all I have, and 7 minutes left. Sorry if I was a bit fast. Is there anything remote? If they have questions, I'm not sure how they can talk to us or raise it. Okay, well, we'll share it. Like I said, we'll share the slide deck. And apologies, it's a bit of miscoordination that I wasn't aware this was a remote broadcast.
A few minutes back, you were talking about peering and transit, the different models, the transit model of payment. Is it at the transit point that the net neutrality debate starts to kick in, and you get to questions about two-speed, the more you pay, the faster you get, priority, and so on, or is it not particularly there?
It's always difficult for me to comment on net neutrality issues because I basically serve both parts of the equation. Now it interacts with what in general terms is transit payments. You see people say like, and part of that net neutrality is the mutual benefit. You've got content, somebody else has got customers who pay to access the internet. That's sort of how it's perceived from a civil society perspective. I pay to access the internet. And it doesn't matter whether I pay to watch Facebook or Netflix or anything. That's where you start to be paid. And yeah, how much does it cost my ISP to serve that content to me? And then the struggle starts, and like, how much cost do you have to make? How do you get return on investment? And yeah, try to persuade other people to pay. From a commercial perspective, the ideal business case for a transit provider, because there are dedicated carriers that basically all they do is carry traffic from content providers to what we call eyeballs and vice versa, is that both of them become a transit customer. Because then you get paid when the packet enters your network, you get paid when the packet exits your network. That's the best deal you can get. From an access provider perspective, and essentially from my customer's perspective, the ideal situation is that everybody goes for settlement-free pairing, because that reduces cost. And eventually that will flow down to me as a consumer in paying less. Anything in between, to a large extent, is just the market at work. It's commercial negotiations. Whether those happen in a fair and balanced way and people have enough choice in a competitive market, I think that's where the net neutrality debate is. Is my operator going to decide how much I pay for Netflix? Or am I going to decide how much I pay for Netflix? That's a bit of the struggle that people have on these terms.
Thank you. I've always wondered how W3C sits. It looks to me very similar.
W3C sits slightly higher up the stack. They basically, for instance, develop the HTML set. So basically the language that is used to build websites, that comes from W3C. So those sit slightly higher up the level, where the transport protocol is the Internet Engineering Task Force. The stuff that sits in the packet, part of that comes from W3C. That answer your question? It's your Annie. You want it back?
Just from the point of control, I mean, say for whatever reason the American government were to pull out the top level domain management, there's a heck of a lot of control that comes just from the language of the internet, the XML underneath it that's controlled at MIT by W3C.
Yeah, well, difficult question. I don't know how far the US involvement in W3C is actually control. I'm not gonna make any judgment on how the balance is. In the end, it's just another voluntary standard that is developed open and in a bottom-up multi-stakeholder fashion. Eventually, my guess is that if there's too much interference from a party, people, for instance, with XML, there are things like JSON, there are other data modeling languages around that are used as well, next to W3C standard. HTML became the de facto standard. Again, everybody saw the benefit of it, and everybody's using it.
But I seem to miss that.
Yeah, I'm not involved in W3C at all. I sit at a lower layer, so I can't comment on. I'm just happy to ship packets back and forth.
I have a question. It's related to my research area, so maybe it's a little bit weird. But I want to know, technically, can one country, either, for example, US or, for example, UK or another country, has the power over internet to cut the change in ICANN and will change this power or not? If to cut off another country from the network and by code, something like that, will that change or not?
No, this is a strictly administrative. It shouldn't change policy, and ICANN policy is pretty clear. Also in country, enough community support to have an operator, you get the country code. North Korea has a top-level domain, and the other example to mention is with all the difficulty people had with Iran, and all the embargoes and everything that went down, .ir has always been kept functioning. .ir is still there. So on the DNS level, no, it shouldn't change. And that's very explicit. The IANA operator works under ICANN policy. And this process only looks at the contracting of the IANA operator. And part of all the proposals is you adhere to ICANN policy, and it's not changing ICANN policy. Technically, unlike making sure the packets get to their destination, it's sort of where you can attach to Gary's comment, where some countries, unfortunately, only have one link up. And if somebody cuts that cable, you're done. So that's why we try to encourage countries to work on your resilience, work on the internet exchange points, get multiple exit points. There's a lovely research work done by our colleagues from Dime. It sort of build an index is like how much at risk is a particular country in terms of using one or two single upstreams. Again, you can also, that comes into trade law, but yeah, if your whole country depends on two transit suppliers, and both transit suppliers are a US company, and the US government, the US Senate pushes down an embargo rule saying you can't sell your services to this country, then that country has to go somewhere else. And we saw that, for instance, with the Ukraine, where a larger registrar that was in the US said like, oh, unfortunately, we can no longer do business with you, and please find somebody else to host your domain names. Yeah, from a policy perspective, that's a commercial decision, and that commercial decision is driven by political exchange. Hopefully not, and hopefully people will respect each other's countries and recognize the value in maintaining connectivity. You can't control it all, and like I said, if somebody cuts a single cable, then it's done. And a lot of times these things happen, and a lot of times these things just happen by accident.
I mean, can I conclude that the main source is in the US, and basically US is deciding which countries are connected or not connected?
No. Every country is, I think it's mostly an independent decision for a country to see where you are connected. Because a lot of times when it comes to building international cables, again, the regulatory environment, how easy is it to invest? It becomes a matter of commercial investments. If I can build a cable system into a country because there is enough market and I've got a return on investment, people are likely to work. If there is a single incumbent that has a lot of protection, people might be less likely to invest. And then it comes down to the government itself and their incumbent to invest. And these things are very expensive. There's one particular problem area, and those are the landlocked countries. It's much easier to build a sea cable than it is to build over land, because then you really rely on your relationship with your neighbors. So there are numerous countries where which we are recognized also in the UN context as having difficulty in that, and there's a lot of effort going on in trying to make sure that these get developed and that they basically get enough support from other countries and from other investors to make this work.
Of course, there's satellite.
Yeah, the satellite works, but it's very expensive in terms of bandwidth. So you would rather run fiber, but yeah, if not, then you have to rely on satellite capacity to get in there.
When you say what is a proxy server?
Ooh, that's a very broad term. There's a lot of different types of proxies. The general concept with a proxy is what we call a web proxy. That basically works a bit similar as the DNS resolver. It goes and requests web pages on your behalf, and then kind of stores it. That's where it originated from. It was to try to reduce the use of international and expensive bandwidth, because a lot of people were looking at the same page. So everybody asked the proxy server. The first one that asks, the proxy server goes out, fetches a copy of that web page, and then serves that web page off to similar systems. It's getting less used because we see more and more dynamic sites, and it's impossible to cache because everything is customized and you don't have a static file. What you do see now and sort of doing a similar job are the content delivery networks, the Akamais and the Cloudflares and a few others that basically take copy of content and put it as close to the customer, as close to the user as possible. And again, reducing the amount of cost. So that's the classic proxy server. Now these days you also see it used, for instance, in Tor networks where proxies are used to basically hide behind other IP addresses. It's no longer a matter of caching, but basically what this proxy does is send traffic across the internet on your behalf, and in the meantime sort of hiding who you are. So that's another. It's a very broad term in technical sense on what is proxy and what's not. There's not a clear definition. Gary?
One last question.
Yeah, there's still people remote.
IANA still has responsibility for arc.arbor and .int. Why is that?
The .arpa kind of comes naturally because it's the reverse DNS, so it's tied with IP address allocations. So as IANA allocates a block of IP addresses to RIPE, the .arpa domain delegation for that block follows that. So it kind of makes sense to keep the two together. .int, can I say no comment? That's a rather it's a rather political point in like, yeah, who owns .int? You kind of get into the same as like, yeah, who controls IANA, who controls .int? And I believe that when .int was founded, people decided that sort of IANA, and that at that time I believe it was still John Postel, was sort of the most neutral body to be responsible for that domain. It's a bit of a difficult thing because not everything around .int is that well documented. I believe it's a lot relies on legacy of the people who were around at the time. Any further questions? We're 7 minutes into the lunch. I hope there's something left. Thank you all. If you've got any questions, I've got a bunch of business cards here. I'll be around for the whole day, so by all means, please do mail me and harass me over lunch or coffee. I'll make sure the slides get posted. I'll have a chat with Laura.
Yeah. Hang on. Stop recording. Yeah. Okay. I'm just wondering what the camera is. I don't know actually. I'm not sure. It's not something I've come across before. It has a pretty clear picture, I think, as well. Okay. No, yeah, of course. Yeah. I can find out for you. If you could you? Yeah. Sorry, I'm Henry.